Let's use a direct comparison test for the following series. You have a sum from n equals 2 to infinity, ln of n over n plus 1. This looks very similar to 1 over n, so we would expect this to diverge. And whenever you expect things to diverge for the comparison test, you want to find something smaller. So if you can show that something smaller diverges, then this series will also diverge. Okay, so how do we get something smaller? Well, one of the ways to do that is to make the denominator bigger. So we want to make the denominator bigger. I'm going to change the 1 and replace it with an n. So if I replace it with an n, I have n plus n, which is 2n. So this is definitely smaller now than ln of n over n plus 1. And for this one, we can figure out whether it converges or diverges by using the integral test. So we would just use the same limits from 2 to infinity, ln of n over 2n, but I'm just going to factor out the 1/2. So we'll use u substitution. We'll let u be natural log of n, du be 1 over n dn. So now we have the 1/2. Now for the limits, these are in terms of n. N is equal to 2 and n approaches infinity. So we would have to plug it into the u equation here. So when n is 2, u is ln of 2. When n approaches infinity, u also approaches infinity. So then we'll just have du over u inside, which would just be ln of u. And here we don't need the absolute value, but actually we should use the absolute value because ln of 2 is negative. So we'll go from ln of 2 to infinity. So this is an improper integral, and technically, to be exact, you need to have a limit to approach infinity. But basically, as u approaches infinity, ln of u will also approach infinity. So this integral is infinite. And by the integral test, this diverges. And so anything bigger than it will also diverge. So by the direct comparison test, this diverges. Let's look at another example. We have a sum from n equals 0 to infinity, e to the negative n squared. This one will still use the direct comparison test. So we'll see how this works. Now, it would help if I just wrote this as 1 over e to the n squared. And the question is, will this converge or not? Well, it would be good to compare this to 1 over n squared. And the reason I choose that is because the exponent. So the question is, which one is bigger? Okay. In general, we know that an exponential is much bigger than a quadratic or a polynomial. So e to the n squared, you would expect it to be bigger than or equal to n squared for some large value of lower n. Okay. So if I flip both sides, the inequality would also flip, and 1 over n squared would be bigger. Okay. So 1 over n squared is bigger. This converges by the p-test. So anything smaller than it will also converge. So that means 1 over e to the n squared will also converge by the direct comparison test.